going to try to solve the problem on screen using something called squeeze theorem. It's the spelling, doesn't matter. Okay, theorem like this. Okay, so for precise definition on how to work with squeeze theorem, just go and check your textbook, but I'm just going to show how to solve the problem using this concept. Okay, sure. So we know that most of my problems, if I'm solving them, they always correlate with the growing the function. We know that a function sine x, let me just draw it here for you, these are my x's. So function sine x should look something like this, something like this. We also know that this function is enclosed, or should I say it's between two functions, the function of -1, which is a constant, that's +1 and -1 here. Okay, so we can say that this function is less than a function of 1 and also more than a function of -1. We got that from the graph that we just plotted, of which we all know how to do it. And then with using that, we can just say now, okay, I think this should be included because it touches there. Okay, so the next thing we want for this function, we don't want for this function that sine x, so we're looking for 3 sine x all over x power 4. So I just multiplied by 3 over x power 4 to bring it back to what I am looking for. Then if I do that, that means here I'll have 3 all over x power 4, and this side I'll have +3 x power 4. We know that now this function that we are required to get a limit for is enclosed, or maybe is between these two functions. Okay, squeeze theorem says if we can find limits of this one and limits of this one and discover that these limits are the same, that means the inner function or the in-between function has the same limit. Okay, so I'm just going to say limit as x approaches infinity of this function x power 4, because this, as the denominator is getting bigger, this number will get close to 0. You know that. And let's try to find a limit of 3 x power 4 as x get close to infinity. I missed infinity here. I have my infinite are bad. How to write infinite? Thank you. Yes, and then from here it's the same thing. As this number get bigger, this one will get close to 0. Okay. Yes, as it gets bigger, it will get close to 0. Remember, we're getting these answers from plotting, of which I really love working with graphs rather than just functions like as text. So this is a hyperbolic function. As I go to positive infinity, I get close to 0. You can see it here, so that's why I get these zeros. Now we just said that the limit of the lower boundary and the limit of the upper boundary are the same. That means also limits of 3 sine x power 4 as x get close to infinity, it will also be 0. Okay, why are we saying this? We're saying this because let me say I have a function like this and other function like this, and this function in between contains a function, an oscillating function like this. Let me say these are where my x's. So if you can notice, this could be a parabolic, or maybe this one or a cos function, who knows, and who cares? I don't. Okay, so we're trying to say that if as I approach this point, this was supposed to be somewhere Okay, as I'm trying to approach, let me use this point. As I'm trying to approach this point, if the lower function is approaching 0 and the upper function is approaching 0 again, that means the inner function that is bounded by these two functions should also approach the same thing. That's what exactly squeeze theorem says.